When the gravitational force of attraction between the Earth and a satellite suddenly becomes zero, we need to consider the behavior of the satellite. Let's break down the concepts involved. 1. The current state of the satellite. The satellite is revolving around the Earth under the influence of the Earth's gravitational force. This force is responsible for providing the necessary centripetal force, which keeps the satellite moving in a circular orbit. 2. What happens if gravity becomes zero? Newton's first law of motion, also known as the law of inertia, tells us that if no net external force acts on a body, it will continue in its state of motion. In this case, the satellite will no longer experience the gravitational pull that was keeping it in orbit. Without the centripetal force, or gravity, the satellite will no longer follow a curved path, such as a circular orbit. According to inertia, the satellite will continue to move in a straight line in the direction of its velocity at the instant when the gravitational force became zero. 3. The direction of movement. The satellite will move tangentially to its original orbit. This is because at the instant the gravitational force ceases, the satellite's velocity is tangential to the orbit. Well, folks, the correct answer is B. Move tangentially to the original orbit with the same velocity. All right, let's dive into the explanation. Imagine this: a satellite gracefully orbiting the Earth, held in place by the invisible pull of gravity. Have you ever wondered what would happen if the gravitational force between the Earth and a satellite suddenly vanished? The satellite moves in a circular path because of the Earth's gravity. This force acts as a centripetal force, pulling the satellite inward and keeping it in orbit. But what if this force disappeared? When gravity vanishes, the satellite is no longer pulled toward the Earth. According to Newton's first law of motion, an object in motion stays in motion unless acted upon by an external force. The satellite will keep moving in the same direction it was heading, right along the tangent to its original orbit. With no force to change its direction, the satellite will move tangentially to the orbit with the same velocity it had at the moment gravity disappeared. This is an example of inertia in space. And that's what would happen if gravity between the Earth and a satellite suddenly ceased: an endless journey through space, following the path of inertia.